What's the general agreement among cosmologists, among physicists, about the beginnings of this universe that we live in?
I don't think there is a general agreement. There is a leading theory which, for the last 30 years, has sort of dominated the field. And this theory was invented by somebody who should have been on the panel tonight, Alan Guth.
We did invite him, by the way, but he had a conflict in his schedule.
Yes. Unfortunately, I mean, this is a theory which I personally have never been convinced by. It is a sort of quick fix, in my opinion. It's a theory which doesn't explain the Big Bang. It doesn't explain the moment of the emergence of the universe. It just assumes that for some reason we can't explain, the universe sprang into existence dominated by a strange, repulsive form of matter, the like of which we don't see today. But you can put this kind of matter into Einstein's equations. It's like a spring, it's like a compressed spring, and it causes space to expand like an expanding spring. And that is the inflationary explanation for the Big Bang. The reason I don't find it convincing is that it assumes the spring was compressed in the beginning. Who compressed the spring? Why was it compressed? So it turns out if you calculate what is the likelihood of the universe to have emerged full of this strange inflationary energy, it's exponentially tiny. It's absolutely negligible. So in effect, they've put the puzzle of the universe's emergence and then expansion into this huge object we see around us, they put that in by hand. I've always felt that way. And unfortunately, the theory is extremely adjustable and malleable because the precise nature of the spring basically is up to you. It's up to the modeler. And so the theory, can be adjusted to fit most observations. Let me summarize it by saying that what observations have shown us is that the universe somehow managed to come out of the Big Bang in almost the simplest possible state it could. It came out, so the pattern of fluctuations on the sky we see today. So if we look out, we look 14 billion light years away, we can measure the temperature in various directions on the sky. And we see these non-uniformities, which we believe are very important because they were the origin of the galaxies and stars and planets and ultimately ourselves. But the nature of these variations of temperature on the sky are incredibly simple. You can describe the whole pattern on the sky with just two numbers. There's an amplitude which tells you the level of them, and there's a slight variation with scale, and that's it. Yet in this theory of inflation, you don't have just two numbers, you have an infinity of numbers, because you have a free function, which is sort of how the spring, as it grows, how it slowly relaxes and eventually goes away, leaving the universe to expand. And so the theory is way more complicated than the observations indicate. So my conclusion from this is we need a better theory, because the great theories in physics in the past did not have this arbitrariness. Maxwell's theory of electricity and magnetism didn't add any new numbers into the game. You had measured properties of electric and magnetic charges, and out of this you predicted the speed of light. Okay, you predicted light and radio waves, and in fact an infinite number of phenomena were predicted without introducing all kinds of ad hoc whistles and bells.
Now, one thing that's been confusing about inflationary theory is that there have been these conflicting reports of data just in the last year. So earlier in the year, there was all this data, too much hoopla,
yes,
that it seemed to confirm the inflationary theory, and just very recently, there is new data coming from the Planck satellite that seems to dismiss that
Absolutely.
earlier study. So what's going on?
What's going on is that the universe has a great way of correcting us. When we have too much hubris and are too full of ourselves and believe our stories too much, the universe comes along and proves us wrong. And that's what happened. In March, there was a wonderful experiment at the South Pole that stared at a certain patch of space and detected a pattern of variations in the temperature. In fact, the polarization, which means the difference in temperature when you measure electric fields coming in two perpendicular directions. So they measured this polarization pattern, and they inferred from this that there were gravitational waves, that's variations in space and time, produced at the Big Bang. And all the advocates of inflation got incredibly interested and excited. And Stephen Hawking claimed that he'd won his bet with me because he bet there would be gravitational waves, and I bet there wouldn't because my theory predicted no gravitational waves. And we'd had this long-standing bet of 10 years, and finally here was the data, and there were the gravitational waves. And people talked about Nobel Prizes, and Alan Guth was destined to get his Nobel Prize, and people were remarkably uncritical. I couldn't believe it. I saw the paper. There were at least 5 glaring problems with the measurement, and yet the world of physics went berserk about this, and people said this is the greatest thing ever. We've seen the Big Bang, you know. And then, you know, the Planck satellite took a lot of additional data, and what they have recently showed just a month ago is that the dust in our own galaxy, because when you look out in space, you're looking through our galaxy, the dust which fills space within our galaxy and itself emits radiation, the dust would generate a signal of exactly the strength seen by this experiment at the South Pole. Of course, no one's interested in dust. It's the most boring thing in the world. But the situation now is that the original claim has completely gone away.